Nick, that was really funny. Yeah.
Yeah.
Man, this video makes me hungry. You want to order some Jimmy John's?
Yeah, I'll come on. Ring, 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 ring. Ring, 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 ring.
Hello?
Hello.
Jimmy John's? 7878 Kaiser Court? Got it. I'll be there.
The loop.
Ah, shoot. Here comes the loop. Better call my Marquette friends.
Hey, Christian. Oh, you're trying to do a loop? Let me quick figure out your initial height that you need and your final velocity.
The loop track consists of an incline that leads to a circular loop with a radius of r. What is the minimum height that a mass can be released from rest and still make it around the loop without falling off? At the top of the loop, the masses enacted on the car are n plus mass times gravity is equal to mass times velocity squared divided by radius. By rearranging this equation and canceling out mass, we get v squared is equal to gr if we allow n is equal to 0. If we multiply this equation by 1/2 m, we get our lovely kinetic energy equation is equal to 1/2 mass times gravity times radius, which is the minimum kinetic energy needed at the top of the loop. For our lovely conservation of energy equation, potential initial energy plus kinetic initial energy is equal to final potential energy plus final kinetic energy. When we substitute our equations and we get mgh plus 0, since velocity initial is equal to 0, is equal to mgh, what we substituted the h for 2r, since the change in y is the diameter of the loop, plus the kinetic energy final, which is the equation we derived up here at the top. When we cancel out mass times gravity, we get h equals 2 times the radius plus radius divided by 2. We do some adding, and now when we plug and chug into the equation, we plug in our radius, which we derived, we measured, is 0.126 meters, plug that in, and we get 0.315 meters.
Now to find the final velocity. We know that kinetic initial is equal to 0 because it started from rest. We also know that the potential final is also 0 because it exited the system. Therefore, mgh plus 0 equals 0 plus 1/2 mv squared. And when we simplify that, we can cancel out the m's. Therefore, gh equals 1/2 velocity final squared. To isolate the final velocity, you take 2 times gravity times the height and take the square root of that. Velocity final equals the square root of 2 times gravity times. Alright, so when we plug and chug the numbers, we'll find 2 times gravity, 9.81, and times the height that we found previously, which is 0.315. Plug that into the trusty TI-89, and you get 2.5. Velocity final equals 2.5 meters per second.
Alright, so from our calculations, we figured that the minimum starting height should be 31.5 centimeters. And so for a test, we start with initial kinetic energy at rest, so 0. Doesn't quite complete the system because it's not an ideal system. We have frictional forces at play. So to compensate for the work done by non-conservative forces, you start with initial higher potential initial. Jimmy Johns!
Wow, that was freaky fast.